What's up, all my friends out there in the math world? It's Rudy here again, and we got another video for you today. This one pertains to my Algebra I students, but as always, anybody can watch the videos that wants to learn something new. I hope you're all staying safe. Hope you're all staying virus-free and hanging out at your homes, not socializing with your buddies right now. I know that seems kind of silly when you're not actually at school. That's what you want to do, but make sure you're being safe. Today's video is for Chapter 2, section or Lesson 7, and today we're going to talk about percent of change. Now, percent of change is one that I like this section because percent of change really pertains to stuff we see every day in the real world. Whether you're buying something, grocery shopping, purchasing something from like Best Buy or Kohl's or like a department store clothes and stuff like that, we a lot of times see percent of change. Whether it's like a sale or a discount or a clearance, a lot of times you go to a store and they say, well, this thing is 70% off of its original price, or we've reduced it by 20%. That really doesn't mean a whole lot unless we understand what percent of change actually means. And also, if you look at what's happening in the world right now, you have a lot of places either reducing interest rates or changing the percentages, APRs, things like that. That's a percent of change as well, right? So let's say I'm a home buyer and I want to buy a new house, right? And maybe 2 months ago, interest rates were at 4 or 5%. Nowadays, they're at 3.5%, 3%. That's a percent of change right there. And that will greatly reduce or change your monthly bills, your costs, your budgets. And so percent of change really pertains to a lot of things we see on a daily basis. So that's kind of what we're going to talk about here in this video. I'm going to show you what is percent of change, why do we care about it, how does it work, and it really ties into the previous lesson we talked about when we talked about ratios and proportions. Because all a percent of change really is, when I show it to you here on the board, is it's a proportion, and it's a proportion that's made up of a couple of ratios. So the real important thing to get out of this is that we're going to be changing percentages, and sometimes it's going to be an increase or a decrease, and how do we use that in our daily lives to help us understand what numbers are changing, how our money is maybe changing, things like that. All right. Okay, so before I jump into the first example, and if everybody's with me, I'm starting off on page, let me find it here. We are starting off on page 119. At the top of page 119, once again, this is Chapter 2, Lesson 7. And on the top of the page, we see example 1, top of page 119. But before I get into example 1, I want to show you this ratio up here. This ratio is what we're going to be using pretty much for everything in this lesson. Although the later examples, we won't use it as much because it kind of makes things a little bit more difficult. I'll show you on the later examples an easy way to actually do them that doesn't involve this. But when we are doing a percent of change, this is what you need to keep in mind. And on your notes, if you want to make it easier for yourself, put a circle around this, star it. I realize it's on your page, but they kind of have it snuck in to the notes on your page. I would write this down separate and keep it in a place that you can refer back to it often, especially when we do the quiz. The quiz is going to talk about this proportion. So the proportion is whatever's changing, whether it's the numbers increasing or decreasing, however much it changes goes up here. Your original amount goes down here at the bottom of the fraction, and we set it equal to whatever the percent of change is going to be. Now for the first example, we won't know what the percent of change is going to be. That's going to be our variable. And remember, percent is always out of 100, right? The word percent is actually a compound word. Per 100. We know cent, C-E-N-T, means 100, like century or 100 cents and a dollar, things like that. So percent is always going to be considered out of 100. Even though we might have a percentage, the ultimate percent of change could be over 100, but we always base it off the number 100, okay? So just to keep that in mind. This is the key, though, to this first few examples. So let's take a look. If you're with me, if you're working on the assignment with me and you're on page 119, let's look at example 1, part A. It says, the original amount was 20. The new amount, or the final amount, was 23. All right? It doesn't give me an actual real life situation, what's going on, but let's say, I don't know, originally you went to a restaurant and your bill was $20. Well, at the last minute, your buddy bought a drink and they tacked on another $3. What percent of change was it? How much percentage did it go up by when he added the extra drink on there? Maybe something like that. So we have our numbers. We take it and we're going to plug it into our proportion, right? So the first thing is, what was the change? Well, we can clearly see if it was originally 20 and it went up to 23, your change was a positive 3. It went up by 3. So we figure out, and you can just do some simple math. You take your final minus your original, okay? And that's what your change is. It's your final, or your new, minus your original. Okay, that's always how you find the change. Take your new or your final minus your original. In this case, 23 take away 20 is 3. So 3 is our change. So now that we have our change, we can plug it into our proportion. So change over original will be 3 over the original's 20 equals percent change. We don't know what the percent change is. That's what we're trying to figure out. So we'll just say, I don't know, P for percent change over 100. Right? So we have ourselves a proportion. And if you remember from the previous lesson, to solve this proportion, we just do cross multiply and divide. So cross multiply, 3 times 100 is 300. 20 times P is 20P. We cross multiplied, now we'll divide. Divide both sides by 20. And these cancel out. We get P. And I remember I showed you a quick and easy way that you don't need to use your calculator in order to actually calculate this. We're going to get rid of the 2 zeros. 30 divided by 2 is 15. Okay? So really what we have here, we have a percent of change of 15. It's an increase of, so we have an increase of 15%, right? Because it's a positive number. Now, if this was a negative, it would be a decrease, all right? And we'll see that in the next problem. I believe the next problem, yeah. The next example is going to have a decrease on it, okay? So one more time, what we did here was found the difference in the change, which was a positive 3, plugged it into my proportion, 3 over 20, or change over original, equals percent of change, which we don't know, divided by 100. Cross multiply, we got 300 equals 20p, then divided both sides by 20 to get 15. And so our answer is an increase of 15%, okay? All right, let's do another one. So if you're with me, I'm still at the top of page 119, example 1, and I'm doing part B on example 1. Let's take a look at another one. So it says for part B, my original My original was 25. My final amount was 17. So we can see in this case, we've had a decrease, right? To find your change, you still take your final amount or your new amount minus your original, right? So that's going to be 17 take away 25. And 17 take away 25 gives us negative 8. So in this case, my change is negative 8. We're going to have a percent decrease, right? And I'll show you that right now. We take it, we toss it in our proportion, okay? So, and I realize I'm changing colors. I don't want it to be one big mass of blue or red. So, take my change, negative 8, over my original, which was 25 in this case, equals percent of change, which I don't know. My percent of change is P over 100, okay? Just like we did previously, we're going to cross multiply and divide. So cross multiply. 25 times P is 25P. Negative 8 times 100 is negative 800. Divide both sides by 25. The 25s cancel out here. We're left with P. And let's see, what is 800 divided by 25? That's going to be, okay, I'm not going to think of it on camera. Rudy could do it in his head. Rudy doesn't want to do it in his head. Wake up, calculator, where are you at? Come on, calculator. Okay, Mr. Rudy's calculator is dead. Don't shame me, people. I'm using a calculator. 800 divided by 25. It gives me 32. Really? 32? That seems awfully high. 800? Oh yeah, it is 32. Okay, sorry. All right, so negative, well, it's going to be negative 32. Okay, so here's the problem. I've seen a lot of people when they answer this, they say, oh, it's a percent of change of negative 32. You don't do that. It's like a double negative, okay? We would say it's a decrease of 32%, okay? So you wouldn't say it's a decrease of negative 32%. You just say it's a decrease of 32%. But that's it. Whether it's an increase or a decrease, it's basically done the same way. All right? Okay, so I'm sure you're all sitting at home laughing at Rudy because he had to use a calculator on this problem. Go ahead. Let's do one more. So if you're looking at the bottom of page 119, we can see there's 4 guided practice problems. There's a 1A, 1B, 1C, and 1D. Let's look at 1D. All right, we'll just do one more just to clarify what we did here, and then we'll move on to example 2. Okay? So once again, if you're working along with me on the sheet, I'm at the bottom of page 119, guided practice 1D. If you're not working along on the sheet, make sure you're taking decent notes, and you can move along with me here. Okay. So once again, we have, for 1D, we have the original of 500. And then we have a new amount of 131. So once again, original 500, new amount 131. We need to figure out our change. So if you recall from the previous problem, to figure out the change, we take the new, or the final, minus the original. So in this case, it's going to be 131, take away 500. And what does that give us? That's 403, negative 369. So we can see clearly it's going to be a decrease, right? It's a decrease of 369. Let's go ahead and plug it into our proportion. So we have the change, negative 369, over the original, which was 500, equals my percent of change, which we don't know, it's our variable, over 100. Cross multiply and divide. So negative 369 times 100 will be negative 36,900 equals 500p. Then I'm going to divide both sides by 500. Five hundreds cancel out over here. And let's see, okay, Rudy's going to use a calculator again. Once again, laugh it up if you want to. 36,900 divided by 500 gives me negative 73.8. Negative 73.8, or if I'm just writing it out, it's a decrease of 73.8%. Once again, you wouldn't say it's a decrease of negative 73.8. That's a double negative. You would just say it's a decrease of 73.8. All right. That's how it's done, my friends, at least for the first example. Okay? All right. If we're working together still, let's move on to the top of page 120. Top of page 120, and it's talking about real world example 2, percent of change. And if you see there, it looks like there's a cruise ship, which cruise industry is not doing so good right now. I think actually all the cruise boats are out of commission because of the virus. So let's pretend this is in a perfect world that's virus-free. I'm going to go ahead and erase this. As always, if you need to, pause the video as you're working along with this. You don't have to watch the whole video, then do the entire lesson. You can kind of work it in pieces. I'd recommend it. Well, let's take a look at the situation. So it says real world example 2, percent of change. Just read along with me. It's talking about the cruise industry. It says the total number of passengers on cruise ships increased 10% from 2007 to 2009. If there were 17.22 million passengers in 2009, how many were there in 2007? So let's keep in mind, let's think about the facts and where they fit into our proportion here. All right? So they tell us, or they do, let's see what they tell us. They give us our percent of change in this case. It says the total number of passengers on cruise ships increased 10%. So we know our percent of change. It says there were 17.22 million passengers in 2009. So we know our final amount as well. We know what they ended up with in 2009. What we don't know in this situation is what the original amount was. That's what we're going to have to solve. It says how many were there in 2007. So they give us our percent of change and they give us our final amount, but they don't give us our original amount. So what we're going to do here with our proportion is we're going to put in whatever numbers we have, and we're going to try to solve for what we don't have. Okay? So I know my change is my final amount minus my original amount. This is what I don't have. So I'm going to put in my final amount, which is 17.22 million. So watch this. 17.22, oh crap, not minus. Let me try that again. 17.22 minus, I'm going to just put X, okay? That's my original amount. That's what I don't know. Over my original amount, I'm going to toss another X in there, okay? 17.22 million minus my original divided by my original equals my percent of change, which I know is 10 over 100. This looks like a hot mess, but it's really not as bad as you think. And we actually had problems like this in the previous lesson. We're still going to cross multiply, but you're not going to cross multiply and divide right away. Watch what I'm going to do here. So I'm going to cross multiply. 10 times x is 10x. And then I'm going to cross multiply here. Now, it's really kind of distribution that we're going to be doing. 100 times the entire quantity, 17.22 minus x. So I'm going to just write that out as an expression. 100 times 17.22 minus x. You following me here? I hope you haven't gone cross-eyed and your head hit the desk yet, okay? Just stick with me. Take that 100 on the left side here, and let's distribute it. So 100 times 17.22 will give us 1,722. And then 100 times negative x would be minus 100x equals 10x. Now we have a pretty easy algebra problem here. Get our x's together. That actually sounds horrible, getting your x's together. Ooh, scary. All right, anyway, I'm going to add 100x to both sides. 17.22 will drop down, or 1,722, not 17.22. These will cancel, and we get 10x plus 100x is 110x. They're like terms, so we can add them together. And now we're going to divide. We're going to divide both sides by 110. X in this case, whatever 17.22, so let's do that. Not 1,722 divided by 110. And that gives me 15.65 if we round it. 15.65. So I'm going to actually get rid of the equals because I'm going to round it. Approximately 15.65. So what does that mean? Well, this is a word problem, right? We need to write the answers out in words. Let's make an explanation. So it says, how many passengers, if there were 17.22 million passengers in 2009 total for the cruise industry, how many were there in 2007? Well, it would be in 2007, there were about 15.65 million passengers. Right? I know we just did a lot, but it really wasn't a whole lot different than what we've done in a previous lesson. Took what we were given, our facts, plugged it into our proportion. Final minus original. Final amount was 17.22 minus original, which we didn't know, so we dropped in a variable, divided by original, which we still didn't know, so we drop in a variable, equals percent of change, which was 10, over 100%, which it's always 100%. Cross multiply, 10 times x is 10x. 100 times 17.22 minus x. Distribute gives us 1,722 minus 100x. Get our terms together. We get 1722 equals 110x. Divide both sides and we get 15.65. All right, let's do another one. Let's keep it going. So if you're with me, I'm still on example 2, middle of page 120, and let's look at guided practice part 2. And I might even do a 2-part video here as well, just to break it up a little bit. But I'm middle of page 120, guided practice number 2. I feel like any moment I'm about to trip over my own feet. So if you all see me trip over my own feet in these videos, It's okay. You can laugh. Feel free to comment below if you want to make fun of me. Nerding it up in my basement. It's alright. I got thick skin. Won't hurt my feelings. Okay. Middle of page 120, guided practice number 2. It's talking about tuition, right? Something everybody can relate to. Talking about tuition. Most of you are going to go to college or do something after high school, and you're probably going to have to pay tuition doing it. Whether it's 2-year, 4-year college, whether it's like a work-study program or an apprenticeship, or maybe you just want to go into a trade school or something, you're going to have to pay tuition. So I guess we can all relate to this problem. Let's read it together. It says, a recent percent of increase in tuition at Northwestern University in Evanston, Illinois, was 5.4%. If the new cost is $33,408 per year, find the original cost per year. So that's already pretty expensive. The new cost is $33,408. And it says the tuition went up by 5.4%. So how much was it originally before they increased the price? So, what are our facts? What can we plug into this? So it says the new or final amount is $33,408. So we'll do that first. $33,408 minus what we don't know in this case is the original amount. So we'll just say C for cost. The original cost over the original cost. Very similar setup as the previous example we just did. Equals percent of change, it says was 5.4%. And it said was a increase. Of course it was an increase. What universities decrease in their costs? I don't see it. There's our proportion, right? 33,408 minus C over C equals 5.4 over 100. Cross multiply. 5.4 times C is going to be 5.4C. 100 times the quantity 33,408 minus C. I'm just going to write it out like that. 100 times 33,408 minus C. Now, just like we did before, we're going to distribute the 100. And that's going to give me, what is that, 33, that's going to give me 3,340,800. I know it's big, but don't worry about that. Minus 100C equals 5.4C. Get my C terms together. It's a negative 100C, so I'm going to add 100C to both sides. Drop down this big number. These cancel out, and we've got 105.4C. Divide both sides by 105.4. And C, or my original cost, will be, let me punch it into my calculator, see, 3,340,800 divided by 105.4, and that gives me, rounded, $31,696.39. So $31,696, and what was the decimal again? 39. Okay, so let's write it out in a sentence. And I'm going to have to cram this sentence on the board kind of in this little area right here. But the question was, what was the original cost per year to go to Northwestern University? We can say the original cost was $31,600, not 900, $600 $1,296.39. And that's all you really need to put down. Okay? All right. Let's see. We're going on 30 minutes on this video. I don't want to make it any longer than that. I'll do a part 2. That way you can kind of digest what I've given you here. Maybe start on some of the problems and then do the second part. Actually, I think example 3, the second part, is quite a bit easier. We're going to talk about sales tax. We're going to talk about discounts. And it's quite a bit easier than the first part. So, once again, get started on the assignment. Chapter 2, Lesson 7. The problems I want you to do are posted on Google Classrooms. I don't have those up at the moment, so I can't tell you. It will be the odd problems, I know that. But watch the video. Watch it in pieces if you need to. And, yeah, I'll see you in part 2 shortly. All right? Thanks, friends.